So chapter 8 is going to start out talking about Pythagorean Theorem. This is something that you have seen before in previous years, previous classes, but today we're going to go more in depth and spend a couple videos on this topic. So Pythagorean Theorem was developed by a man named Pythagoras in 500 BCs. He and his followers believed that everything in life could be described through numbers. So he developed a way to determine a straight line distance from one point to another if you're just going left, right, up, and down. So a right triangle has a right angle. It has three sides. There are two legs and one hypotenuse. And the hypotenuse is the biggest side. It is always across from the right angle. So C is the hypotenuse, and A and B are the legs. So the legs are connected to the right angle. The hypotenuse is always across from the right angle. So what Pythagoras actually did, and some other mathematicians have proved this later on, was used actual squares. That a square with side length A, a square with side length B, if you were to cut those shapes up, it forms a square that is as big as one with side length C. These didn't show up properly. I'm not sure why. Let's rewrite this. A squared plus B squared equals C squared. So if A squared plus B squared equals C squared, then going on this line, triangle ABC is a right triangle. And for all right triangles, it has to be true that if A squared plus B squared does actually equal C squared in terms of area, then it actually is a right triangle. So we want to start by finding x. All right, we have our formula. A squared plus B squared equals C squared. And I'm going to start plugging things in. I could choose which one of these I want to be A, which one I want to be B. That doesn't matter, but C has to be 10 square root of 2. So as I'm going through this, let's call A 6 root 3. So 6 square root of 3 squared plus x squared equals 10 square root of 2 squared. 6 square root of 3 squared, when you type that in your calculator, be sure you're using parentheses, because when you type it in, you don't, one of the most common mistakes is we type this in incorrectly and we get 18 as an answer, and our answer is not actually 18. When we do 6 square root of 3 squared, we actually get 108 plus x squared equals, and when we type this in, we get 200. Sorry, that looks like a 3. So x squared equals, when I subtract 108, I get 92. And we take the square root of both sides. X is the square root of 92. Now, if I type square root of 92 in a calculator, I get 9.59, and it keeps going on forever. It's an irrational number. So what we want to do is we want to start making a factor tree of 92. So I'm going to make a factor tree by splitting this into factors of 2 and 46. And 46 goes into factors of 2 and 23. Now, my three factors are 2, 2, and 23. To go outside of the radical, when we're simplifying radicals, you need to pair. Think of it like the buddy system. You need a buddy to go outside. So our pair of 2's goes outside the radical. What's left uncircled stays inside the radical. 2 square root of 23 is the same as square root of 92. Now, in some instances, you're going to leave it as square root of 92 because there's more work involved. On a test or quiz, multiple choice answers are going to be simplified like 2 square root of 23. So, my goal is to find x. First off, because this shape has right angles in the middle, and I'm going to tell you that all these are the same, this is actually a rhombus. A rhombus has diagonals that intersect at a right angle, forming 4 right triangles. So we have one side that's 16, one side that's 14, and one side that's x. So a squared, let's call that x squared, 14 squared equals c squared, which is the one across from the right angle, 16. So 14 squared is 196. And then 16 squared is 256. So x squared equals 60. When I take the square root of that, x is the square root of 60, I want to make a factor tree. 5 and 12. Going into 12 is 4 and 3. And going into 4, 2 and 2. So I've done my prime factorization, and I've gotten 4 factors that are all multiplied together to get to 60. If I did 5 times 2 times 2 times 3, I would get to 60. So I have a pair of 2's. That goes outside the radical. What's left uncircled, let me switch colors. The 5 and the 3 go back in the radical, and we remultiply them together to get 15. So 2 square root of 15. Let's try going the other way. Find the perimeter of a rhombus that has diagonals of 16 and 30. So let me put a parallelogram out here that looks like a rhombus. Okay, and one diagonal is 16, the other diagonal is 30, and diagonals bisect each other. So that means those are both 8, and these are both 15. So when we start doing this, I'm going to look at one triangle. I'm going to look at just this triangle on the left. This triangle right here. And let's bring that triangle over so we can just look at it outside of the shape. That's 8, that's 15, and this side is x. So 8 squared plus 15 squared equals x squared. 8 squared is 64. 15 squared is 225. 64 plus 225 equals x squared. We get x squared is 289, and 289 is a perfect square. When we take the square root, we get x is 17. So since that's 17, and it's a rhombus, I know all the sides are 17. And the question asks us to find the perimeter. The perimeter of the shape is 17 times 4, 17 plus 17, 4 times. So the perimeter is 68. Find the side of a square whose diagonal is 4. So when we draw in a square, the diagonal of that square is 4. So these are both the same because it's a square. X squared plus x squared equals 4 squared. A and b are both x. So I have 2x squared equals 4 squared is 16. I'm going to divide both sides by 2. X squared equals 8. And then when I take the square root, I get that x equals the square root of 8. And we do a factor tree to solve. 4 and 2, and 2 and 2. Now when you look, you have 3 2's, but we only circle them in pairs. So each side is 2 square root of, there's a 2 left uncircled inside. So finding the side of a square is that. Remember, I can find perimeter now by just multiplying that by 4. Now we're going to look at an isosceles triangle and try to look at the same thing. So we have an isosceles triangle with legs being 26 and the base is 18. What we want to do is we want to find the altitude. The altitude, remember, is the line that goes straight down from a vertex, forming a right angle. So if that's 18, because it's isosceles, those actually get split in half. So this is 9 and this is 9. So I'm looking for one of my sides. I'm going to look at just half of it. 26 is the hypotenuse, so a squared plus b squared equals c squared. 9 squared is 81. And 26 squared is 676. So x squared equals 595. And if 595 is not a perfect square, which it is not, because of the size of the number, don't worry about making a factor tree. Just leave it as the square root of 595. If I type that in a calculator, I get 24.39, and it keeps going. So I'm going to stop there. Example 6. Find the altitude of an equilateral triangle. So now instead of an isosceles triangle, we're looking at an equilateral triangle. There we go. Which means all three sides are the same. They're all 8. And since I need to find the altitude, which goes straight down, forming a right angle, I have a right triangle, and since this whole side is 8, it's split into 4 and 4. There's x, so a squared plus b squared equals c squared. Oh, almost got ahead of myself. 4 squared is 16, 8 squared is 64, 64 minus 16 gets me 48. So x squared equals 48. X is the square root of 48. So I'm going to make a factor tree. Going into 48 is 12 and 4. Going into 12 is 4 and 3. And I could take both of these 4s, and I'll do this in a different color and show you, and do 2 and 2. Oops. And do 2 and 2. The only issue is then I have a lot of factors. I'm also going to look at, because I found a 4, and I found a 4, there's my pair. The one that was left uncircled was the 3. 4 square root of 3. We're going to practice in class simplifying radicals, so if that's not something you're comfortable with, be sure you're asking a question.